We already know how to find HCF using prime factorization. But what if the numbers are large and prime factorizations become lengthy? There is another very useful method called Euclid division algorithm. But before we learn the algorithm, we first need to understand something very simple: Euclid division lemma. Don't worry, if you never studied it before, we'll understand it step by step. Let's start with something you already know. Suppose I divide 17 by 5. 5 goes into 17 3 times and 2 is left. So we can write this as 17 equals to 5 multiplied by 3 plus 2. Nothing complicated so far, right? Now let's give these part their mathematical names. 17 is dividend, the number we are dividing. 5 is divisor, the number by which we divide. 3 is quotient and 2 is the remainder, what is left after division. So the basic idea is simply dividend is equals to divisor multiplied by quotient plus remainder. Euclid's division lemma tells us that if we have two positive integers, we can always write the first number in the form of a equals to bq plus r. Here a is the dividend, b is the divisor, q is the quotient and r is the remainder. And there is one important condition: the remainder must always be less than the divisor. For example, in our question, the remainder is 2 and the divisor is 5, so 2 is less than 5. Now comes the interesting part. We are going to use this simple division idea again and again to find the HCF. Let's find the HCF of 225 and 135. First, take the large number 225 and divide it by 135. 135 goes into 225 one time and we are left with 90. So our first equation is 225 equals to 135 multiplied by 1 plus 90. But we are not finished yet. This is where students often get confused. We don't stop after getting 90. We take the previous divisor 135 and the remainder 90 and divide again. So now we divide 135 by 90. 90 goes into 135 one times and 45 is left. So our next equation is 135 equals to 90 multiplied by 1 plus 45. We still have a remainder, so we continue. Now we divide 90 by 45. 45 goes into 90 exactly 2 times. Nothing is left, so our remainder is 0. Now we stop. Now remember this rule because it is most important part of the entire method. When the remainder becomes 0, we stop and the last non-zero remainder is the HCF. Here the last non-zero number is 45, therefore the HCF of 225 and 135 is 45. So why do we call this an algorithm? Because we follow the same steps again and again. Divide, find the remainder, use that remainder for the next division and keep repeating. When the remainder becomes 0, the last non-zero remainder gives us the HCF. One very common mistake is to take the first remainder as the HCF. Remember, that is not correct. We have to continue the division until we get a remainder of 0. Only then we take the last non-zero remainder as the HCF. So here is the whole method in just 4 steps. First, divide. Second, find the remainder. Third, use the remainder and divide again. And finally, when the remainder becomes 0, the last non-zero remainder is your HCF. And that is Euclid's division algorithm for finding HCF. If you understood the method, try to find HCF of 391 and 299 on your own. Write your answer in the comments. Don't forget to subscribe for more class 10th maths.